here. We're going to skip. Well, no, 4 is just kind of another day of conic sections, like how do we recognize conic sections before it's going to be pretty skipping. And then 8-6 is three-dimensional. We're going to talk about that. There's some polars up here, but we're going to kind of see that part. So we're just at name. So that's it. That's all in the material, right? Again, the plan is going to be to take our test next Monday. I think that's not really that much fun, but it gives us more time to review the final. So that means next Monday, I'll do homework for chapter 2. And then that also will give you time to review the attendance. It will give you time. All right? So hyperbolas look a little scary because they have these asymptotes in there, but the equation for hyperbola is very similar to the equation of ellipse. Just to kind of talk about, it says a set of all points in a plane such that the absolute value of the difference of those two distances from the foci. So a couple big differences between the ellipse and a hyperbola. In a ellipse, the foci, like here are your vertices, the foci are in the middle of it. In a hyperbola, the foci are on the outside. Also, we can talk about this focal axis, or in a hyperbola, they call it the transverse axis. I don't know why they can't just call it the focal axis again. And that's the axis that the vertices are on, that the foci are on. Just like with an ellipse, that could be flipped. If the transverse axis is vertical, then you're going to have a graph where you're going to have something that looks like this with your asymptotes going through there. Something I wanted to talk about is if you connected this, and don't draw this on yours because it would look weird. Think about if you connected like this, where this is your A unit, this is your B unit, like that makes an ellipse. So for me, I think about a hyperbola is it's like breaking the ellipse apart and flipping it outwards, and then it kind of makes these branches of the hyperbola. So that's kind of one way to think about it as well. I promise it's not as scary as what everybody says. All right, but I'm going to give you some formulas. We're going to talk about what do you need to know in order to do this. All right. Maybe we should talk about this. I'm going to go and write on this one. On this one, right, this is your A from here. Your B is still like the minor axis, only on this one they call that the conjugate axis. And then your C is inside there, right? From here to a focus is C. So we can still relate A, B, and C, but now C is the biggest one. Okay, so in the ellipse, A is the biggest one. In a hyperbola, it's C squared equals A squared plus B squared. So that's really easy to mix up. So you just got to remember in the ellipse, A is always biggest. And hyperbola, C is always biggest. Okay? But, yeah. So kind of some of the things I said already, that an asymptote, right, we've seen those before. Just like everything we've done with asymptotes, if you can find your asymptotes and your vertex, then your graph is just going to kind of follow those, so that's really nice. The distance from the center to a vertex is A units. That's exactly the same definition of a vertex in an ellipse. The distance from the center to one of the foci is C units. That's exactly the same as in an ellipse. The length of the axes are exactly the same. We're just calling them something different. The transverse axis, aka the focal axis, aka the major axis, is still going to be 2A. It's just going to be A each way. The other axis, they call this one the conjugate axis. For us, that's the minor axis. In a hyperbola, the minor axis isn't really like, you don't connect anything to it, but we'll talk about how it's helpful with our asymptotes. And that's still going to be 2B units. And oh, look, I put these squares. All right. So again, if you've been doing ellipses, if you've done the ellipse homework, it's not much different. It just kind of leads to the question that Jessica asked on the worksheet, which again, minus sign is between those two fractions and the plus sign. And that's how you get an ellipse versus a hyperbola. All right? So the next slide here is my lovely handwritten equation. Again, two shapes depending on which way it opens. So if you want to draw the picture up here, horizontal is like the one that I just drew on the first page, where your branches are horizontal or your vertices are horizontal.
vertical means you're going to have it look something like this. I didn't put the one where the center is at 0, 0 on this one. We can write that at the bottom. But hopefully, this is our fourth one, that if you recognize if it's at 0, 0, it's just going to be X for the Y squared on top. If it's not at 0, 0 for the center, then it's going to have to be K up there. So it's the exact same formula for ellipse, except for right there is a minus sign in between them. So our formulas for the vertices and the foci and the co-vertices, that's kind of like the minor axis, exactly the same as an ellipse, meaning that the vertices, you just find what A is, and you go A units either left or right, or up or down, depending on which way it opens. So the way that looks in the formula is if we're going horizontally, we're going to add and subtract A to the H value. So that's why it's H plus or minus A, comma K. And if you're moving your vertices up and down, you're adding A to the K value. So that's why it's H, comma K plus or minus A. And the foci, just like with an ellipse, we're just moving it C units. So it's going to be exactly the same, except for we're going to change that A to a C. And again, just like with the ellipse and the parabola and all that other stuff, I don't memorize this page. I just know what A means and what C means and which way I'm moving it. The co-vertices, that's the B value. So that means it's going to go the opposite way, right? So if your vertices are going left and right, your co-vertices are going to go up and down. So that means we're going to add B to K. And if your vertices are going up and down, then your co-vertices are going left and right. Again, just like the minor axis, which is why I feel like if you've done the ellipses, there's not much difference. Okay, before I show these asymptote equations, they look a little scary as well. Don't freak out about them because I'm going to show you an easy way. The slope of those asymptotes has to do with A and B, because either you're going to go up A over B to get your slope, or you're going to go up B over A. It all depends on where A is horizontal or vertically. And then the rest of it just have to do with the H or K. So this is a linear equation, slope-intercept form, sort of. It's really more in point-slope form, but here we go. So y minus k, that's just the y minus k from your center, plus or minus b over a, because there's two asymptotes, one with a positive slope, one with a negative slope. And then x minus h is going to be that point. And so it's really like point-slope form, where you take y minus y1 equals m times x minus x1. Makes the most sense to use the center as that point, since you have it already. And so I'm going to show you a really quick way to draft asymptotes, and then we can use the graph equations if they ask for it. And notice, if it goes vertically, all that changes is our slope, because now vertically is going to be A, and horizontally is going to be B, whereas on this one, vertically is B, horizontally is A, to do those. C is the foci. And just like with an ellipse, the foci doesn't show up in the equation, right? That we have to find C whenever we ask for it, because we only get A and B from the graph. And then I put this here if you want to write those down. Oh. I feel like we've seen this enough with the center at 0, 0 that it's probably okay. You know, I think the best practice of these is just doing some problems, because as you do the problems, you don't have to feel like you have to look at this as a crutch. I hope you haven't been looking at this as a crutch. Because if you just know what A and B and C are, it's exactly the same as they are in the ellipse. And the form of the equation, then you don't have to feel like that's well. For the first year I did these asymptotes, I was always like, how am I supposed to know? And now it seems like so perfect sense of like, oh, B is vertical or B is horizontal. We can also talk about eccentricity with hyperbolas, but we're not talking about how circular something looks, because you saw those two branches of the hyperbola that's not circular at all. So there's little extra things that are different with the eccentricity. It's still the same formula, but think about in a hyperbola, C is always bigger than A. So that means that it's always going to be bigger than 1. It's just going to be, is it close to 1 or is it really far away from 1? So if it's a really big number, that means that those two branches of the hyperbola are going to be really flat, which means like they're just going to be very wide. That's how I think about it, if it looks going to be really flat. As opposed to the smallest that can be, right, it never can be exactly 1. It can be really close to 1. And then they're going to be like more pointed. And I can draw a good picture of that being like if they're really curved like this, right, that's going to have a really small eccentricity as opposed to one that like sometimes I can roll really, really big ones, but like that, like that's a really flat parabola. All right, so that's kind of the eccentricity. All right, so let's start with one that's in the right form, and then let's practice flipping the square to put it in the right form. So, I've said don't stress a lot about formulas. The one formula that you should be making sure you know, maybe worthwhile to make some flashcards of, are the basic formulas for an ellipse, a hyperbola, a circle, and a parabola. Knowing that they're both squared, knowing that they're equal to 1, knowing that there's a minus sign in the middle, that's the hyperbola. It's in the right form, so I can just start doing everything in this problem. Right? So, well, in an ellipse, we have to find C2, right? Right? Because in an ellipse, even when you put it in the right form, still you only have A and B. Here's the big difference. There's a minus sign here, right? Here's the other big difference. In an ellipse, A is always the biggest number. In a hyperbola, A is just the positive one. So A is not always the bigger than B. Sometimes it's smaller than B, like in this case. So in this one, when I look at this and I see that Y is first, right? So this is telling me that A is 4 and B is 5 because A is always the positive one. Remember, in an ellipse, sometimes A was listed second, and it didn't matter because you can add it in the order that you want. You knew which one was A because it was the biggest. In a hyperbola, you know which one is A because it has to be the one that's positive. Usually one of the So my center here, what would my center be? One, -6, right? HK, so that the one with the X first, so 1, -6. And then, to find my vertices, because A is under Y, that means it's going to be up or down. That means I'm going to be moving A units up or down, right? And if you want to graph it first before you write this out, you can. But that's how I think about it in my head. I don't have the formula memorized, but I know that this means up or down. Up or down means it's going to move the Y coordinates. So my vertices are going to be adding 4 to -6, which would give me -2. And subtracting 4 from -6 would give me -10. Right? Always, if you do your graph first, you can just find those points on your graph and move them over. If you do this first, you can still count it on your graph and make sure those match up. Just like with an ellipse, the foci aren't really necessary to graph, but they oftentimes ask for them. And just like Matt said, you're going to have to solve for C, and you have to remember that C squared is the biggest one on this one. Yeah, because that's not going to change, right? It's going to be on the same axis. All that's going to change is it's moving up or down. So every time on the vertex, either the X is going to stay the same or the Y, depending on where you're moving it. The square root of 41. Again, if you wanted to graph the foci, you could get a decimal and you could actually do it just like we did for the vertices. What I do is I just write it as plus or minus the speed value there. So just like the vertices, the ones are going to stay the same, but then just moving up or down, C units. So I'm just going to write it as -6 plus or minus the square root of 41, because otherwise I have to do decimals. I don't do that. kind of graph what we have, and I'm going to show you how you can graph these easily and how you can graph the asymptotes really easily, and then we'll go and write those equations. We do need a negative 10 on this, which is why I tried to give you a longer y-axis here. We don't really need a lot of x values. A 6 hours homework quiz that they took last Friday, the one that we just took, that graph one. So people didn't label their x and y axis at all. Like they didn't even put tick marks. Like they just had a straight line and they put a dot. I can't give you credit for just a dot if I can't count what it goes by. And as long as you just put tick marks like that, I always just count them by 1. If you want them to go by something other than 1, you have to label that. That's just kind of something to think about as you're making your graphs on here. So if I start with my center, your asymptotes are always going to go through your center, so that's always a nice point to go with. Your vertices, because y is under a, I'm going to go up and down that. So that's what I mean by, if you don't want to write these out yet, if you just have your center and you know a is 4, you can just go up 4, 1, 2, 3, 4, and you can go down 4, and then you can use that point to see that it's 1, negative 2, and it's 1, negative 10. Hopefully just like you did with notes. Because this is a squared, right? Because I had to go from negative 6, right? So I added 4, and I subtracted 4 from negative 6. And start their center, not at 0, 0. So here's where the asymptotes are helpful. Because if we didn't have asymptotes here, we would have to just keep picking points to see how to make these. So the conjugate axis, the b value, like if this was an ellipse, right, then my b, I'm going to go left and right 5. So let's make it on some here. Let's get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If this was an ellipse, we would connect that, and that would make an ellipse, right? If that was a plus sign there and not a minus sign, that's what we would do for an ellipse. Okay? But we want a hyperbola. So here's where the asymptotes come into play. The asymptotes are going to be, my slope's going to be like rise over run. So you can kind of think about if you made a rectangle of these 4 dots here, right? So like, see if you can humor me for a minute. If I did like a dotted line this way and down this way, you see how I can make a rectangle out of those, the vertices and the co-vertices? Your asymptotes will always just be the diagonal of that rectangle. Or some people don't even make the rectangle, they just say, like, they just in their head go up and over and they just make the point there. Or down and back. And that's going to be an asymptote. And you also have to do the opposite. It's a negative asymptote too. So I can go up A and back B, or down A and over B, right? Those are the diagonals of that. And that gives me my width of how wide I need to make these branches. And this one's going to be pretty wide, right? If I'm going to use this point and kind of go out and follow that, right? I don't know why I'm making a straight line. See how wide that is? If I go this way, and I go out and I follow those asymptotes. Because that's your A and your B, so that's your rise over run. So all those dotted lines are not part of the graph, but it's just a way to kind of help you. And in your book, they do the exact same thing. Maybe their graph is in your book, page 657 at the bottom, it says a drawing lesson. And it shows making this rectangle and how you can use that rectangle to be your asymptote and to kind of get a boundary for your hyperbola. Otherwise, you're making an XY chart at different points. So if I was going to do my asymptotes, right, back in the day before I learned this little trick with the rectangle, I would actually find my asymptotes and work it out in slope-intercept form so I could graph them. I don't need to do that anymore. I can just use the equation, which is y minus k, so y plus 6 equals, it's always going to be plus or minus, because there's two of them, and your slope is just either a over b or b over a. And you can just look at this and think about, oh, well, a went up this time, so it's up a over b, so that would be 4 over 5 times x minus 1. And there is no reason that you have to work that out anymore. You could work it out in actually just an equation, but there's no need to do that because every time your asymptote will go through the center and through that diagonal there of that rectangle. Questions on that? It looks ugly, but they're really not that true. Okay, the other thing that we have to do, just like on all the conic sections, is you've got to be able to put it in this form. But so on this one, I can see that the x is squared, but there's no other x to go with it, so that means I don't have to complete the square for x squared, right? That means it's just going to be a 0 up here. But the y needs to be completely square, right? And tomorrow we're going to talk about how we can recognize which one it is before we do this. But I'm going to leave my x squared, and then I have to put my y's together, and I'm going to go ahead and factor the 9 out of that, because you have to factor out a number in front before you complete the square. So that would be y squared minus 4y. Leave a spot, and I'm going to move the 72 to the other side. Half squared is 2. 2 squared is 4. But what am I adding to the other side? When there's a number in front, remember you have to multiply that too. So 4 times negative 9, I'm actually putting in negative 36 on the other side. And then that's going to factor into y minus 2 squared. That's going to give me 36. And I can see already that minus sign, and even if I didn't know this is hyperbola, that's what tells me it's a hyperbola, because if it was an ellipse, it would be a plus sign. I need to divide by 36. So I get x squared over 36 minus y minus 2 squared over 4 equals 1. Questions where I got that? So now, looking at this, because x is first, because x is positive, I know that my branches should be going horizontally. I know my vertices are going to go horizontally. So you always want to kind of think about that. Make sure your graph matches what's here. Because there's nothing with the x, I know the center starts at 0, but then the y is at 2. And the directions here just said sketch, which means if you're just sketching the graph, you don't need C. If you have it in the right form, all you need is the center and A and B. We have that, right? This is A squared, so I know A is 6. This is B squared, so I know B is 2. You know which direction you're going here. 0, 2 would be right here. Since x is the positive one, I'm going to go left and right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to go up and down B. Those are my co-vertices. It's really nice when you have the greatest body here to do that, because I think if you think about that rectangle, right, the diagonal is going to be where these two intersect, which is going to be always over here, down here, over here, up here. So I'm not going to make the box this time. I'm just going to make my asymptotes, which always seem to be very curvy. Here's where you gotta be careful. If you have 4 dots on here, make sure you make your branches in the right direction, right? So if it helps, like label which one was the vertices, but it was left and right. So this time it's gonna be a lot smaller, right? The eccentricity is gonna be very different on this one than on the last one. Because they are definitely more pointed. Our asymptotes are closer together on here. You just have to graph it. You don't have to list all that stuff. Which means if you can put it in the right form and you know what A and B are in your center, you should be able to make that up. Questions on this? Alright, I have one more here. Let's see if we can do this really quick. I'm trying to remember if this was this. Remember when you factor out a negative, it changes the sign here? That's wait, that was I hope we're getting pretty good at using the square, right? Not easy to be practicing, and you're definitely going to have to compute the square on your test. Remember, when the number's in front, we have to multiply it. So again, this one's just going to be a plus 4. I have to take 4 times 4 to the other side. Yes, yes. Oh, thanks. I didn't even pay attention to the 1 over there. Half of 8 is 4, and 4 squared is 16. Which gives me negative 144. So look what happens on this. You get 4 times x minus 2 squared minus 9 times y plus 4 squared. Then when you add these together, you get 1. Right, like it always has to equal 1. Like normally if we had a 4 and a 9 over there, this would equal 36. And we divide through by 36. But it has to equal 1, so it's like what you can't divide by 36 right now, because then that would equal 136. So can you think for a minute and think about if I wanted to write this as x minus 2 squared over something, and I can't divide, what does A have to be in order for that to be a 4 up there? Yes, we could think of it that way, yes. So what are you thinking? Well, but that's not the same number, right? If you do 16 over 4. What kind of number, what could be down here that when I simplified it would just make a 4 on top? That was a 1/4 in the bottom. If I have this divided by 1/4, is that the same as 4 times that? Yeah, it means your A and your B are fractions when you get something like this. It would be a really teeny tiny one. It's really hard to grasp this. And the same thing with this. You could write this. I'm not changing anything. But instead of putting a 9 on the top, if I put divided by 1/9, is that the same? Like that would flip up and be a 9 on the top? Which is why they would write it like this, because it looks much better. But if you were going to graph that, A would be 1/2, and B would be 1/3. I put on here, these 4, I want you to graph those. If you need more graph paper, I can give it to you. If you have other graph paper, yeah. You just need to know, like, if I asked you what A and B were, you need to know, right? Like, if it's one of those tricky things, I just want to show you. Everybody have more graph paper? And Matt, I guess just go there now. We did tonight, but I'm sorry. I don't report. Look at your class. Everybody else, you graph paper there. Whichever one doesn't have a line. Unless for some reason they necessarily get it out front. That's one thing. Again, the way I always write it, I always just say this. Okay? I'm working on it.